Welcome back, Year 9. So hopefully you've had a nice weekend, a nice rest, and now you're ready to start the next science lesson for this week, which is going to be on osmosis. This is an osmosis practical which follows up from the osmosis and diffusion lesson that we completed last week. So just a couple of reminders before we start. Make sure your phone is turned off or it is in a different room. And then you don't have any other tabs open on your computer except this video and then the booklet, which is called Investigating Osmosis, and you either want this printed or electronically open on your computer. This booklet can be found the same place as you find your worksheets every week, which is in the Continuity of Learning part of the John Smeaton website under Science Year 9. As well as the booklet, you'll also need a calculator because we're going to be doing some calculations this week, and then you'll also need a pen, a pencil and a ruler if you are writing your answers on paper. Remember, even if you haven't got a printer at home and you haven't been able to print out these worksheets, what you can do is just complete the work on some lined pieces of paper. It would also be good if you have a different colour pen as well, so you can mark your answers we're going through. I want you to try and answer every single question, and when I ask you to do independent work, I want you to pause the video while you have a go at this. You can always rewind the video if you're confused or struggling on any part of the lesson, and remember there's always BBC Bite Size to go to as well if you're struggling. So if you type in BBC Bite Size Osmosis, you will find the practical that we're going to discuss this lesson. And then finally, don't give up. You are doing absolutely fantastic, Year 9, so keep going, and another massive well done to you. So then you should have your booklet open by now, the Investigating Osmosis booklet. The first part of the booklet is some do now questions. I'd like to have a go at these do now questions independently, so you can either have a go at them on the Word document on your computer, or you can jot your answers down on some lined paper, or if you have the booklet printed you could do that as well. The answers are on the next slide. We're going to go through the answers and you're going to mark your answers, but first I'd like you to pause the video now, have a go at these questions independently, and then restart the video and we'll go through the answers. All of these questions should be a recap from last lesson. So how did you do? Let's find out. Question 1 asked what substance makes the cell wall rigid. So cell walls in plants are made up of cellulose. Remember, cell walls are only in plants, not in animal cells. So give yourself a tick if you got it correct, or change your answer in a different colour pen if you didn't. Next question, which substance moves by osmosis? Water. Water is the only thing that moves by osmosis. Remember, osmosis is just a specialised form of diffusion, and it just means diffusion of water. So the movement of water from a high to a low concentration. Number 3, what can happen to cells when osmosis happens? So either water can move into a cell and make the cell swell up, or water can move out of the cell and it can shrink. Or if water is just moving at the same rate in and out of the cell, it will stay the same. Question number 4, what 2 factors can affect how quickly diffusion happens? So temperature, concentration difference and surface area are all acceptable answers for that question. So improving your answers if you didn't get it 100% correct in a different colour pen. Number 5, why do diffusion and osmosis happen? And they happen because there's a concentration differences. There's a concentration gradient. If there's a different amount of particles in one place compared to another, then diffusion or osmosis will happen. Last question, number 6, what does a high concentration of water tell you? It means that the solution is very dilute because there's a lot of water in the solution, meaning that it's very dilute. meaning there's a high concentration of water. Just like if you've got very, very dilute cordial blackcurrant juice, you would say that's dilute because it's got lots and lots of water in and hardly any blackcurrant. So tick in your answers, adding in any detail that you missed out, and then we'll move on to the next slide. So pause the video while you do that. Let's have a look at what we will be doing today then. So in this lesson we're going to have a look at a practical, an osmosis practical, and we're going to have a look at some evidence that osmosis happens. So whilst we're doing this practical, you're going to identify variables to change, measure and control to test a hypothesis. We're going to have a look at a method and you're going to explain the reason for each step in that method. You're going to process some secondary data, and then finally you're going to describe and explain the results obtained. As well as this lesson that I'm going through with you now, Miss Marsden's also going to be video recording herself doing this practical and uploading it onto the continuity of learning science section. So that will help you in this lesson as well. You'll be able to see how Miss Marsden carries out the practical, just like you guys would have been able to do if we were in school. So I just said to you that Miss Marsden is going to carry out the practical and video herself carrying out the practical, so you can see how you guys would do it at school. But you could also do a similar experiment at home, which would allow you to be able to see osmosis happening. So I want you, if you've got some potatoes at home, I want you to have a go at this practical. And you can set this up now, so pause the video, set the practical up, and then by the end of this lesson, so in about 30 minutes time, you'll be able to go back to your practical and you'll be able to see the results. So what I want you to do is go and find a potato, and I want you to cut it roughly into equal sized discs or cubes. So you want them to be about the same size. Then I want you to take 2 glasses of water, and I want you to put the same volume of tap water into the 2 cups. Remember, we don't say amount of water, we say volume if it's a liquid. So you want to add the same volume of water into the 2 cups. And then into one of them, I want you to dissolve 3 tablespoons of salt. So add the 3 tablespoons of salt and then stir it until it's all dissolved. I want you to put one of your equal sized discs, potato disc, into each cup, and then we're going to leave it for 30 minutes, and after 30 minutes you're going to have a look at the potato discs and see what has happened. So off you go now if you want to set up that practical. So remember last lesson we said that if cells are put into a solution where there's a very, very high concentration of water, then water will move into the cells, and that will mean that the cells will swell as more water moves in. We also said if cells are put into a solution where there's a low concentration of water, so quite a salty solution, then there's going to be more water inside the cell at the start, so water is going to move out of the cell into the solution, and if water is moving out of the cell, that cell is going to get smaller, so it's going to shrink. Or it will stay the same if the concentration is the same inside the cell and outside the cell. So it depends on the concentration of water in the solution compared to that of the cell. If there's a concentration difference, then osmosis will occur. So we're going to look at the effects of different solutions on cells. So we're going to have different concentration of solutions, and we're going to see what happens. Does osmosis happen? Which direction does osmosis happen? And this is much easier to do with plant cells, much easier to observe with plant cells than it is animal cells. So we're going to use plant cells. So If you take a look at your Investigating Osmosis booklet, underneath the Do Now task is the method. And this is the method that you guys would have carried out if you was in school. This is also the method that Miss Marsden is going to carry out on the video that she uploads as well. So remember, you could stop the video now and watch that video while you're reading through the method, or you could just watch the video at the end of the lesson or before you come to complete the independent work. So I want you to read the method, stop the video, read the method, and then I want you to try and identify the independent variable. The independent is the thing that we change on purpose. What is the dependent variable? So what are we measuring each time with the different solutions? And then the last one, what variables would you need to control? What things would you need to keep the same? So try and do that and try and write down the 3 different variables underneath the method. Read the method, identify the variables, write what you think the variables would be. So now you should have read the method and tried to identify yourself what the different variables are. So the independent variable, the thing that we are changing each time, is going to be the concentration of the solution. So the different concentrations would be, well, what we're going to use is 0.2 molar, 0.4 molar, 0.6 molar and 0.8 molar sugar solution. So in this investigation we're going to use sugar instead of salt to change the concentration. The dependent variable, what would we measure each time? So we're going to measure the change in mass of the potato, because if water is moved into the potato, then the mass is going to increase because the cells will have swelled and would have more water in them. If water is moved out of the potato, then what's going to happen is the cells are going to shrink, less water in them, less content in the cells means they're going to get lighter, so there'll be a decrease in mass. And then what variables would you need to control? What would we need to keep the same? So we'd need to keep the volume of solution the same. So in this investigation we're making sure the solution is at 15 centimeters cubed each time. The size of the potato piece, so if you carried out the home experiment earlier, you have made sure you have equal sized potato pieces. And then the time that we leave the potato in the solution for, because osmosis is going to happen at a specific rate. So if we leave the potato in the solution for longer, then more osmosis is going to occur. So we have to keep the time that they're left in the solutions for the same. So improving your answers, green pen in your answers now please. This is now an opportunity for you to pause for thought and make sure that you understand what the investigation is trying to determine. So I'm not going to go through these questions, but I want you to pause the video, have a look at the 4 questions on the slide and have a think about what you think the answer is to these questions. There's no need to write the answers, but you can make notes if you'd like. So what should we expect to happen to the potatoes? Remember, potatoes are made of plant cells. We could have used something else. We could have used carrots or parsnips, which are also made of plant cells, but we've just decided to use potatoes in this investigation. So remember, the cells will either shrink or they will swell depending on the concentration difference across the membrane. So if water moves in, they will swell and the mass will increase. If water moves out, the cells will shrink and the mass will decrease. So these are the questions that I asked you to think about independently. The first one is, what do you think would happen to the different pieces of potato? So we will expect that the potato will either shrink or swell as the cells shrink or swell. And if they swell, we've already said we'll have an increase in mass, and if they shrink, we'll have a decrease in mass. Why do the tubes need to be left overnight? We need to leave them overnight, or at least for a couple of hours, to make sure that there is a measurable change in mass. If they aren't left long enough, then the change might be too small to measure, especially with the quality of weighing scales that we have in school and you guys have at home. Why would measurements to 2 decimal places be a good idea? And that gives, so 2 decimal places gives us a good resolution. It means you could detect even a small change. Last question, why would the potato pieces need blotting before reweighing them? They need to be blotted, and all I mean by blotted is take a paper towel and dab them, to make sure that any water on the surface of the potato is removed. Otherwise, that water on the surface would add to the mass and wouldn't be an actual demonstration of how the mass of the potato had changed due to osmosis. So going back to your booklet now, I want you to complete pages 1 to 2 of your booklet. You might have already looked at the variables. You might have already completed the variables while we were going through this earlier. But for pages 1 to 2, you need to be really sure that you understand the method and you understand why we carry out each step in the method. So it'd be really useful if you stop my video now, and then go onto that link that we've also provided for you where Miss Marsden is carrying out this practical in school, because this allows you to see how you would carry this method out in school, and she will also go through explaining the method a little bit more. So pause the video, watch Miss Marsden's practical video, and then have a go at questions 1 to 2 on your worksheet. Then we'll go through the answers. So you probably did this already earlier on in the video, but question number 1 and 2 asked you to identify the variables. So the independent variable was the concentration of solution. The dependent variable, what we measured, was the change in mass of the potato. And then the control variables, things that would keep the same, are the volume of solution, the surface area of the potato cylinders or cubes, however you cut them, the temperature of the solution, because remember, temperature can increase how fast diffusion and osmosis happen, and then the time each potato cylinder is left in the solution for. The next part of the sheet asks you to explain why we carry out each step in the method. And it's really important that you understand methods, especially for required practicals, and this is a required practical because required practicals can get asked about and will be asked about in your GCSE exam. So it's important you understand the method and also the variables that are attached to the method. So the first step in the method is to cut the potato cylinders to the same length and diameter. This is important because we need to make sure the surface area to volume ratio is the same for each cylinder. So the size is the same for each potato cylinder, so that osmosis isn't affected by the surface area of the cylinder. We want to make it fair for each potato. Next one, leaving the tubes overnight, and this is important because it gives enough time for a mass change to be observed. If you only left them in for 10 minutes, osmosis doesn't happen as fast enough for you to see a huge change. Why do we dry each cylinder? Why do we blot each cylinder before making mass measurements? And this is because excess water on the cylinder surface will affect the mass measurement. It'll say that the mass is larger than it actually is. And then the last question, make mass measurements to 2 decimal places, and this is to give us a really high resolution, so then it allows us to see even very small changes to the mass. We've now carried out the practical, we've looked at the method, we understand the method. We're going to have a look at the expected results. So after the pieces of potatoes have been left for the specific time, so maybe overnight, they've been removed, blotted and then reweighed. This means that we can calculate the change in mass. So the change of mass at the end compared to the start, did mass increase or decrease. To minimise the effect of any differences in the starting mass, the percentage change is calculated, and we do this by we calculate the percentage change by doing the change in mass divided by the original mass times by 100. But I'm going to go through this with you on the next couple of slides. So whilst I'm going through the next couple of slides, have page 3 of your booklet open and you can be filling this in as we're going along. So on page 3 of your booklet you should be able to see a table of results. I'm going to go through the first set of results, so the first row with you first, and how you calculate the change in mass and the percentage change as an example, and then after that you're going to have a go at the other rows yourself. So to calculate the change in mass of the potato cylinder, which is the 4th column along, what you need to do is take away the starting mass from the final mass. So my final mass of the potato for the first result, so where the concentration of sugar solution is 0, my final mass is 3.07. My starting mass is 2.60. So what I'm going to do is 3.07 take away 2.60, and that gives me an answer of 0.47. You need to make sure you include a plus or a minus sign in front of your changing mass, because this shows whether we've had a gain in mass or a loss of mass. The next thing we have to do is the 5th column along, is to work out the percentage change in the mass of potato cylinder, and this is to make all the results comparable. So to find out the percentage change, we have to do the change in mass divided by the original mass times by 100. So for this example here, my change in mass I calculated was 0.47, so I would do 0.47 divided by my original mass, which is the starting mass, which is 2.60, so I would do 0.47 divided by 2.60, and then I would times that by 100 to get it into percentage. And my answer would be 18. It'd be plus 18, so I'd have a plus sign in front of that percentage, so plus 18%. So now we've had a go at the first one together, the first row. I'd like you to calculate the change in mass of the potato cylinder and the percentage change in mass for all of the other rows, so all of the other concentrations. So for example, the second one, you're calculating the change in mass first, so you would do 3.04 take away 2.71. And then you would calculate the percentage change in mass after that. So stop the video and try and calculate the change in mass and percentage change for all the other concentrations now. Remember, I went through the other one with you, the first example, on the previous slide, so you might want to flick back as that goes through it as a worked example if you're struggling. You can use your calculator, that's absolutely fine. So pause the video and try to calculate the rest of the results in this table for me now, please. So now quickly checking your answers, hopefully you've got them all correct. If you've not, go back and check over them again using my worked example. Ticking them if you got them correct. Making sure that you've included that plus or minus sign as well. So in a second I'm going to ask you to complete the final task, which is task 3 in the booklet. But before you do this, I want you to just pause the video, look at the results, and then think about these questions, these 4 questions. If you set up the home experiment, now would also be a good time to go and check it and see what has happened to the pieces you left in the water and salt solution. You saw this slide at the beginning, but it's a good reminder of the effect that can happen to cells. So cells can either shrink or swell, depending on whether water moved into them or out of them. So now I'd like you to have a go at task 3 in your booklet. Whilst you're doing this, whilst you're answering task 3, which is like you concluding on the practical, you need to say which solution was the most concentrated, so the most dilute, because when we talk about concentrated we mean the most concentrated with water, so that would be the most dilute solution. And then you need to use this to explain the movement of water. So is water moving out of the cell or into the cell? So I've included some sentence starters to help you with this conclusion. The first sentence starts with some cells gained mass because, so some cells gained mass because what? Was there a higher concentration in the solution or a higher concentration inside of the cell? So have a go at completing these sentence starters under task 3 for me now. Now let's check our answers and see if there's anything that we missed out. So some cells are going to gain mass because they were surrounded by a solution with a higher water concentration. So they were surrounded by a very high water concentrated solution. Lots and lots of water in the solution compared to inside of the cell. So water is going to move from the solution into the cell. Lots of water moving into the cell by osmosis, and the cells are going to swell. If the cells swell, that will mean that they gain mass. Making sure you got that word osmosis and you got those keywords high water concentration in there as well. The next one, some cells lost mass because they were surrounded by a solution that was lower in water concentration, so the opposite. So there was less water in the solution than there was inside of the cells. So water is going to move out of the cell because there's a higher concentration of water in the cell, and it moves by osmosis, it moves from a high to a low concentration. So water is going to move out of the cell into the solution by osmosis, and this is going to cause the cells to shrink and lose mass. So in the second part of this answer, you want to make sure you still got the word osmosis in there, and then you also got the word shrink, and then you talked about how there was a lower water concentration in the solution. If you completed this home experiment, I want you to get the 2 pieces of potato in front of you now so we can have a look at what has happened to them. So one we had in salt water and one we had in plain water. The one that we had in salt water, where would a higher concentration of water be? Would it be in the salt water or would it be inside the potato? For the one that we had in salt water, there was a much higher concentration of water in the potato compared to the salt water. So water is going to move out of the potato cells, the plant cells in the potato, into the salt water. And if water moves out, the cells will shrink, so the potato should have shrunk as well. And that would mean it would decrease in mass. And then the second one, where the potato was put in just plain water, there's going to be a much higher concentration of water in the plain water compared to inside of the potato, in the potato cells. So what is going to happen is water is going to move from the solution, it's going to move into the cell, into the potato cells by osmosis. This is going to cause the cells to swell, so that potato should be larger than the other potato. And because the cells swell, they're gaining water, which means their mass is going to increase as well. If you didn't see a massive change, you might need to leave the potatoes in the solutions for a longer time. So you could even leave them overnight. Well done guys, you've reached the end of this week's content. So now all you need to complete is the fluency test, which is on page 4 of your booklet, and then you also have your Educate quiz to complete. Please remember that you need to send some proof that you've done the work, so either a photo of your work or the Word document, to your science teacher so we can update our tracker. Otherwise, we will think that you haven't done the work. There's also some optional exam questions that you can do as an extension task which test your knowledge on this topic, osmosis and diffusion, which have been uploaded on the Continuity of Learning Science section. So that's up to you if you want to do that. But I'd just like to pass on another well done again for getting to the end of this week's content and keeping up with these lessons. You're doing absolutely fantastic, Year 9. Please keep it up.